All right. Right, it's right there. Fuck it. Hello, chat. We're gonna go for an old exam. So here, so it should be the April 22 exam. So this one here. So I'm just gonna close all the other ones here. I was originally gonna put them in the stuff, but I won't do that now, I don't think. So we're gonna go here. So the goal is to go through and understand all of these questions and such, and potentially able to ask some good questions in like 2 hours. When the thing is, what's the word I'm looking for? I can say the run through, but that's not a very good word for what I'm trying to say. The exercise session where he's gonna go through some parts of this exam. We're allowed to use anything we want. I've decided to understand it through the lens of Jeopardy, so I've asked it to break the problem down into what the things are, and then go step by step on how to do it. So I'm basically going to just write this down on my piece of shit paper and talk to you guys a little bit about it whilst I do it. That's the goal. I hope the microphone is fine from here. I don't have the I can actually go get it. Give me 1 second, chat. I think it's in here. I can actually hear if the audio is fine. Yeah, here it is. Oh no. There's a bunch of other fucking things that's just in this damn bag. So I always just carry around. There's a little compartment for a bunch of different cords. Oh no! Shit, my god. One of them is what's this one? Gonna go here, and then gonna go here. Oh lord! All right, there we go. Now I can hear myself. It seems about right. The microphone seems to be able to sit about here. Not any major issues. I have this damn. Can I push it back? I can't really push it back any further. That's slightly annoying because I want to see a little more space. I'm really annoyed at the screen that's behind me. Because I could push this here and put there and stuff. Like that could sort of work. There's a bunch of cords and stuff everywhere. I don't know if I bother to do that. Yeah. So let's just the theory behind. Oh, that's a B, not the D. That's super matter, but I might actually put this in my analysis. That's almost. What What is it? Dimensional analysis. I think like just writing this down is like is a technique. Used to understand like how I would say how different quantities relate to each other in terms of physical interaction. Understand the relationship between quantities by focusing on their fundamental dimensions. Yeah. The relationship. God, this fucking. I feel like it's been in water. It's so wobbly and shit. I don't know if I'm gonna use this piece of shit paper. I have something here I could use. I can also use the gun, get my iPad and write on that. I should probably do that. Give me like 1 second, chat. I'm just gonna go and grab my iPad. It should be upstairs. It should be done charging by now. I think that makes a lot of sense. This thing is wobbly and bad. Just gonna put that there. Grab a Coke. It's the good shit chat. Alright. Give me like 1 second. I will be back. Yeah, fine. Dramatic. Hey chat, give me 1 moment. Alright. I brought my little bird friend. He's gonna try to learn today too. I'll see how that goes for him. He is just a baby, but he's also very kind and snuggly boy. So, you know, a lot of good qualities to have when you're trying to learn things. Yeah, that felt awful to write with earlier. Does my pen needs to be charged? If it does, I'll kill myself. Okay, it will need to be charged at some point. It won't last 4 hours, but maybe we can write a little bit. You know, something. So I'm actually just gonna go like dimensional analysis explained. Whatever. No, I need to fix it. I will annoy myself for the rest of eternity otherwise. Explained. There we go. Go. What is? Oh, this is a little nicer. What is dimensional analysis? Question mark. That's the question. Let me put the question in a different color. I don't like that color. Let's check a different color. Sure, that sort of works. We make it like a little thicker. That's a little too thick, but let's go with it anyway. Dimensional analysis is a technique to understand the physical relationships between different can I write different fundamental dimensions? Yeah, that's okay. So there, yeah, that's what they're called, fundamental dimensions. That's a bad N. Dimensions such as, and then they have mass, length, time, electrical charge. Sure, those are good examples. Such as mass, big M, length, big L, time, big T. Check here. Now I gotta. You don't have to work at the moment. I quite a lot to hand in other situations. Electric charge Q. Yeah. I like how they've written this basic idea. I'll write this in a slightly thicker, in green maybe. I like this green. That's a good green. Each. Oh lord. Physical. They say quantity. I would want to say phenomena, but those are different things. Can be expressed in base. Let me make this text just a tiny bit smaller so I can. In base dimensions, e.g. mass. I mean, it's just these examples again, right? Kill off those ones in front of. 2. When forming a dimensional Dimension less one. Quantity which is a number without units. The product of various quantity raised to some power should have no residual. Yeah. It isn't like a red because it is a key point. The product of various quantities raised to some powers should not have a residual dimension. There we go. I think I wrote this text in a yes, it's slightly thicker. That's fine. I kind of like this slightly thicker pen that I have right now, actually. I went up a size in pen, and it helped me. I think it's worth like writing this down again, right? Because it helps it to really sort of stick. At least that's the theory. So when you multiply I want this in a different, let's do this in purple, I don't know why. ME to the power of A, K to the power of B, E to the power of E. Is that a C? I think that's supposed to be a C. Yeah, that's gotta be a C. C H bar to the power of D and E to the power of F. You want the net exponent on M L T and Q to be 0, and I'm going to highlight and draw a little box around to be 0. Oh, I did it in the wrong pen. How embarrassing. Come on. I mean, I could just have the regular little red box that I did draw, but sure, it can be written like that. Looks, yeah, to be 0. Sure. You want that exponent there to be 0. And then third point. By translating each Fishman's constant and variable into its base dimensions, you get a system of equations for the exponents a, b, c, d, and f. Yeah. And sure, we can write common dimensions together on section here, like this. I mean, I'm literally just writing, changing out some words here and there, but generally, like, just making sure that, like, by writing these steps down for myself, I digest the information a little better than by just reading through it. Like, oh yeah, I've learned about this. I was on this lecture. I followed along. I have done some of the things about it. It was a little while ago. I do need to refresh it, which is what I'm doing. So we got the electron mass me, which have dimension. Come on, brain, you can write. This has dimension m for the mass. We have Coulomb's constant k, which have, it's a little lazy, I just copied the dimension thing. I'm just gonna assume that, I mean, I can look it up. Coulomb's constant, which is Newton meters. I suppose that's meters squared divided by c squared, which is the light. Check Wikipedia. Because it's looked about right? Because this is not, that's not the formula. That's a constant that it's in. That's a force. That's a distance squared, and then these are electrical charges. Let's see if we just control F die. Oh, it's not in here. It should be here in there somewhere. Well, there definitely are somewhere. Let's see if we can find. about him, which is I want the diamond. Okay. Coulomb's constant dimension. A. Why is this a different answer from Euclides? This is ml squared t to the time lengthened, because length isn't a base unit, right? No, right? Okay. Dimensions of f, right? Okay, yeah, sure. So the dimension of f, mass, length, time, IT or AT. I'm not sure I understand. So this is just a different notation for what these things mean, right? I need the base notation. MLT squared. This I agree with. It's mass times length divided by the time squared, because it's the mass and the acceleration, and acceleration is length divided by the time squared. MLTA. What is A in this case? What's the dimension of K in coulombs? Oh, basic equation. It's the thing we're using here, right? Gotta be the thing we're using. Right, so I think they're using, because if we compare ML ML3, and then they have a T squared, there's a T4. Then they have A squared. So A is Q. So it's the electric charge. Sure, you can do that in both, I would say. This oh no, I'm moving the microphone. Are you sure about the dimensions of Coulomb's constant? Derive it for me. Yeah, so this is the formula. I agree with this. This is the one for this here. I agree. The distance. Yes, I agree. Charge is Q. I agree. So we have L to the power of 3 times L times the T squared, T and Q. LT squared Q squared. What did you write here? Yeah, that is the formula you wrote down there. T squared. Oh, he writes Q as AT. Okay. Area times, oh no, A is ampere time. Because that would change the T's. Yeah. Fundamental physical constants. Right. Universe is referred to universal but dimensional physical constants such as those mentioned above. Increasingly, however, physicists reserve the expression of the narrower dimensionless universal physical structure constant alpha, which characterizes the electric. Okay. So what a list. In base SI units. Like here, I just want the fucking, I want the SI units, I suppose. Yeah. All SI units now. This is sort of what I'm looking for. Yeah, because it would be ampere. Yeah, you want these things here. Right, so time, length, mass, electric current, which is different because that's in ampere, whilst if you check up here somewhere, where we are here, when we're doing here, we're defining, I mean, it's not like, because if we look up the Wikipedia article for electric charge, electron charge, like it is a very fundamental and important thing, and it makes this is even in coulombs, which is in and of itself an SI unit, correct? Coulomb, which is S times A, which is like which is then Q, right? So if we check here, E and T, right? Because this S is seconds, so it's ampere sekunder, or seconds time ampere. Like it makes sense to do it that way. But these are the fundamental ones that everything then is built upon, correct? So these are the ones that you gotta like be able to use, so to speak. That these are the dimensions which something can be in, so to speak. So TLMN, TLMI, temperature. Yeah, so it's time, length. So the amount of time something takes, the length of the thing, the mass of the thing, the electric current of the thing, the thermodynamic temperature of the thing, sure, the amount of a thing in terms of like the quantity of it, of the number of atoms, I would assume is like the thing there, and then the luminosity, which is a frequency thing, right? Which is like, yeah, right. So actually, like a thing that I would want to that I actually want to have like sort of clarified for me then. Questions. Questions for examination, sure. When doing what's it called again? Dimensional analysis. Dimensional analysis. Should I define Coulomb's constant L cubed T minus 2 Q minus 2 where Q is electron charge. Since electron charge is Coulomb and Coulomb is ML cubed T. Well, I should probably write it like this. T minus 2 times A minus 2 times T minus 2, which is ML cubed T minus 4 times A minus 2. Same thing expressed in a more or less convenient way how should I think about it? Let me actually go to the Wikipedia page for SI units. I want to see if he has tweeted anything else fun. Yes, not what we were supposed to do. SI units Wikipedia. SI wait, which one are we using? International System of Units. So we're using this one at the moment. Okay, this one. We have the SI defining constants. I'm not super interested in those. They are useful because they are how we describe the fucking world. No, it's a fucking. Why is it so annoying to? God damn it. Is there a way to no? Can't make this fucking smaller. Wait, if I do this, does it become like? God damn it! It just barely doesn't fucking fit. That's so annoying. I don't have to fucking send screenshots to myself. I guess I'm gonna have to. Oh, that's annoying. Just a bunch of prefixes. Coecto minus 30. And queta 10 to the power of 30. And a rona. That was apparently put in the 90s. Back in the 90s, I was in this very famous TV show. I'm gonna start asking for like a decaliter of something. Yeah. So give me like a second to chat. I'm just gonna need to take a few screenshots and stuff. Just throw it over to my iPad. I particularly want to open up my so you learn stuff on stream. So I'm just gonna turn this off for a moment whilst I fix that. Basically, yeah, I won't need these things here. So we're gonna take a screenshot here. I'm just gonna throw them to Messenger to myself. I think that's like the fastest way of doing it. So that thing here. Go here, take another screenshot here. Wait, there's a column here, which is annoying. There you go. I would have been annoyed at myself. Go here, here, here. Close this thing, and then we turn this thing on again. This thing on again. There we go. Okay, we're back, chat. We're back. We are also back. Yeah. I'm a little tired. I do have a hard time focusing on any like longer time periods, but I do my best. Download it. There we go. Maybe I did. Maybe I have it twice now. Who knows? So we can let us see here now. I did put it in twice, like a dumbass. Big stupid dummy. That's what I am. If you guys didn't know. Wait, like put it down like a few rows here. Something like here, so this versus this. Right. When is it a good idea to use the electron charge E's dimension as Q? Check here, right? Like it makes sense to do these things quite often, because like it can get a little annoying otherwise. SQ, it is a Coulomb which is technically ampere seconds, which has the Hej, det är Marcus.
Jo, hej, det här var Elisa Padeco.
Ja, tjena.
Tjena, jag tänkte höra om du har möjlighet att jobba någonting imorgon.
Nej, det kommer nog tyvärr bli lite svårt där.
Ja,
tyvärr.
Men då markerar jag det i kalendern, så får du ha en skön jul så länge.
Ja, detsamma. God jul på dig.
En god jul.
Ja, så vi så. Hej. All right. Precis. Så. Per second. That's not a Spellwitch. which has the dimensions time and ampere. So T times A. I'm curious what it has to say about that. In principle, the dimension of electric current can be expressed in the terms of the base SI units for electric current, ampere, and time. Since 1 coulomb is in ampere seconds, we have Q equals A and T. However, when you treat charge Q as its own independent dimension or break it down within the context and the goal of your dimensional analysis, when to use Q as an independent dimension. Simplicity in problems involving electromagnetism. When performing dimensional analysis in problems that focus on electromagnetic interactions, like Coulomb's law, define structure constant at atomic energy levels is often cleaner and more intuitive to introduce Q as a separate fundamental dimension. By doing so, you directly represent quantities like charge, primitive, or Coulomb's constant without repeatedly referencing current and time. This makes the analysis more straightforward when comparing electrical and mechanical dimensions. This is a key sentence. This makes the analysis more straightforward when comparing electrical charge and mechanical dimensions. Right, because otherwise it's unclear makes it more clear what influence the compared to mechanical dimensions such as time if we measured if your goal is to connect all physical constants back to the strictly defined SI base units, meter, kilometer, meter, kilogram, second, ampere, Kelvin, mole, and candela, then expressing HAT is the more fundamental approach. This can be useful if you want to understand how a unit like a coulomb relates directly to the SI definition of the ampere. You're dealing with a more general dimensional analysis that must integrate seamlessly with other SI units when analyzing current-dependent phenomena. In some areas of physics and engineering, such as circuit theory or electrical meteorology, it can be more meaningful to see how a charge relates to current and time explicitly. For example, if you're analyzing a problem where the current and time scale is more fundamental, like in circuit analysis or defining standard units, expressing Q as A times T makes the physical interpretation cleaner. Q as an independent dimension if your primary aim is to keep the analysis of electromagnetic phenomena neatly separated from the conceptual straightforward. Break Q down into A times T if you need to relate everything back to the pure SI base units, or if the problem at hand benefits from being explicitly the relationship between charge, current, and time. If we measured Q through like a sensor, then makes sense, then it only makes sense as its own Q dimension question mark. Use Q as an independent dimension. Dimension if oh Lord, what the fuck is happening? If your goal is to keep the analysis of electromagnetic phenomena separated and straight. Oh Lord. Forward. There we go. You should put a dot there as well. All right. That's what Jupiter said. Yeah, right. Like, what type of dimensions should we use? Can really shit. I have spent like an hour on the first question. I mean, I am writing a lot of stuff down here, right? So I need to actually do the thing which we're supposed to do. So I'm gonna speed the fuck up. These parts here goes a little faster. Yeah. But I need a very quick poop. And we're gonna continue. Finish this boy up, and then we're gonna need to speed run through the other ones. But I do want to write it down properly. I might actually turn the stream off for a bit. Sure. I think I'm gonna do that. Because I am just writing stuff at the moment. So yeah, let's just call it there for now. I might stream a little bit in the evening, depending on how things go. But thank you guys.